There's a lot of traffic. Wow, and standing room only at the back. Please take a seat, take a seat. Thank you for joining us, all of you. AI is certainly a hot topic, so I feel, am I getting feedback here? All right. All right, I hope that's better. So we've got four very interesting panelists who are actually dealing with AI in different perspectives. So we'll start off by getting a very brief kind of 30-second, 60-second rundown on who they are and what they're working on right now. Start at the end, Binru. You're working with Ping An, a division of Ping An. So just give us a quick rundown of what you're doing at OneConnect.
Yeah. Hello, can you hear me? Yeah, okay, very good. So I run OneConnect, which is the fintech subsidiary of the China Ping An Group. So Ping An is the largest insurance in China. We also have the Ping An Bank, as well as some asset management companies, so end-to-end financial institution in China. OneConnect only does the technology, so we commercialize what is being used within the Ping An Group to the other financial institutions in Southeast Asia. Singapore is the HQ for Southeast Asia.
Right,
yeah.
Thank you. Charles is at Appier. Charles, go ahead. I think you're wrong.
Hello, my name is Charles. Sorry. My name is Charles. I work at Appier. I'm the VP of Enterprise AI. Basically, I lead our enterprise department. So Appier is a technology company, and our focus is in the AI realm. And our goal is really to help companies grow using artificial intelligence solutions.
Thank you.
Sure.
Is that mic? Can someone at the back get another mic down here for Charles? I think it's... You'll have to shout in future, Charles.
I will try.
There we go. Oh, that's much better. All right. Please go ahead. Tell us more about what you're working on.
Sure. Can you hear me? Testing.
So apparently AI cannot fix AV problems, so we'll see if we can get through.
It might be able to fix it, but it might not be employed yet. It might not be commercialization ready at this point.
Tell us what you're going to do about that then.
Right. My name is Tonio Buonassisi. I'm a professor at MIT and a principal investigator at SMART, which is MIT's research enterprise here in Singapore. My mission right now is to accelerate the rate of new materials development by 10x. So we use materials in our daily lives, plastics, metals. These have certain origins. They have certain costs at their end of life. My goal is to make the planet more sustainable by using AI to develop better versions of those materials 10 times faster.
That's fascinating stuff, and I'm going to get back to that in a moment. And we're going to bring in Lewis here from Element AI. What is Element AI?
So Element AI is a company founded out of Montreal from Joshua Benjo, one of the three fathers of deep learning. Our startup is now 500 people, and we're in Asia. I run the Asia operations of it. We specialize in advanced techniques of AI, like deep learning, for example, and our goal is to build enterprise solutions, either product or even advisory, that helps customers bring in AI into the enterprise application space rather than just pure labs or innovation criteria.
Cool. While you've got the mic, I'm going to get you to give us a very quick rundown on the way you define the difference between AI, deep learning, machine learning. There's so much terminology around now. Some people in the room will know exactly what we're talking about, and a lot of people will get confused. So give us a rundown on what you see as the differences between those three.
All right. So I told that I was going to explain this without using any terminology. Let's see if I can do it. You have a 7-year-old. Your 7-year-old, you create a list of the exact steps they need to do so that they can cook an egg. That sad list of steps, that's traditional AI, an algorithm. And to be fair, we've been doing AI since the 1950s. That 7-year-old, now you teach them to learn how to do an egg. You take that 7-year-old and say, you do this, you crack the egg, you turn the fire, and the egg follows that, the 7-year-old follows that, and it does it repeatedly. The 7-year-old learns how to do that procedure. That's machine learning. You have your 7-year-old, and you say, cook an egg. And the 7-year-old looks at every information that's around in the house to figure out how to cook an egg. And not only cooks an egg, it cooks it much better than you've ever done it. It figures out a very different way that you've ever cooked an egg. And you tell them, how do you learn that? And the 7-year-old says, by looking at all the data. And that's deep learning.
Wow. Give him a round of applause for that explanation. So going back to that point then, it seems to me that one way to look at it is machine learning is just really repetition, continue iteration. whereas deep learning is much more about adaptation. Is that right?
Well, so machine learning is about us teaching the machine what to learn. Deep learning is more about the machine telling us what is statistically relevant for a learning. So what we've been proven now since 2016, for those of you that know the AlphaGo movie, is that machines can be better at defining inferences, at creating new learnings, than humans. Imagine that this 7-year-old now has the competence and the ability to do what 100 people can do. And the reason I refer to 7-year-old is because it's still a 7-year-old. It still needs to be guided, right? But when you have the ability to run faster computations than humans, you will, by statistical definition, arrive at better inferences than humans will.
Well, definitely you're getting into terminology there
Yeah,
with
I said the
inferences
first part,
and
that's the second part
statistics.
terminology.
But that's okay. There is a lot of jargon around, a lot of maths involved.
Yeah.
I want to actually now talk to Binru and Charles about the technology that you're deploying in very real-world commercial scenarios. And Binru, tell us about what you're trying to do to deploy obviously in the fintech space, which is a great area for AI, deep learning, machine learning. I'm curious to know, what are the biggest challenges you've faced in the last couple of years? Is it a lack of data? Is it a lack of processing power? Is it a lack of personnel and human resources?
Yeah. So all our solutions are AI or blockchain based. I'll just pick maybe the simplest example. So like facial recognition. So OneConnect in China has 2 billion times of calls of Chinese faces via facial recognition. So we could pick out the fair faces, the Chinese faces very well. And then my job is to deploy it to Southeast Asia. So it took us a bit of time to actually start recognizing to the same level of accuracy the Indonesian faces, the Thai faces, as well as the Vietnamese faces, etc. Today we realize that a lot of data is required in the country, and the challenge is not the lack of data. The challenge is the algorithm needs to be trained in the country, given that this data cannot leave the country. I think that's the first challenge. Technically, there's no challenge getting to that accuracy level over time. So as long as you have the data and you can train the algorithm in the country, it can be done.
Is that all it needs is time, which is basically a lot of number crunching, right? You just keep gathering data, you keep crunching numbers, you keep doing it over and over time. Is there anything else to it? For example, noise. I mean, there's so much data around. How much of that data is valid? And that must be part of the process, right? Sorting the wheat from the chaff, the good data from the bad data. Is that something that you face as you move into a new market?
Yes. More, not the challenge is not with the tech, it's more with the business processes. Like for example, the eKYC that we're trying to implement so that everybody can stop using your OTP PIN and SMS so that you can use your mobile phone and using your face, authenticate your card.
eKYC is know your customer.
Yes.
OTT over the top.
Yes. And that algorithm is supposed to learn on its own. So the more you use it, the more accurate it is in identifying your features over time. And then what we've added is also the voice, so that you can say your name and it can authenticate, say your ID card with your face and then your voice. So the challenges is with the process in the country. Like for example, Philippines had 17 different IDs. And this is no single ID for you to, so the algorithm is more baking that process in, and the resolution of the IDs, I think, the pictures and the resolution of the ID. So to a certain extent, no lack of data, lack of quality data may be the challenge, yeah.
Charles, you, I guess, would face similar issues, but you're very much dealing with digital data, humans on their digital footprint in the ad space. Do you find you're coming across possibly different challenges that she's facing? She's facing the problem of 17 different IDs in the Philippines. What is the challenge that you face with all the data you have to gather?
I actually do want to stress on this data point as well. I think most people, when they have this phrase where they say, garbage in, garbage out. Right? That is actually a very true phrase, but I don't like this phrase because it's not very subtle. Okay, it implies a couple of things. It implies that there are only two types of data. There's bad data, garbage data, and there's good data. But in reality, if you're running some sort of AI project, that's not the case. You're very seldom going to get into situations where your data is garbage. Usually what happens is that your data is imperfect, right? And you can still run very good AI algorithms on top of imperfect data. What I mean by imperfect means that, for example, it could be incomplete. You're not collecting all the data that you need. it could be not unified. You're not able to tie data together. So these are things that you have to work around, right? So what we end up having to do often is we end up having to do this in parallel. So you're building AI algorithms, and it's actually it's the responsibility of a data scientist to have the judgment to know what to do when you have imperfect data. But at the same time, you're spending a lot of effort making sure that your data is improving over time. So I think that's actually one of the biggest challenges.
So it's a two-part process. So you're saying every bit of data you get has some kind of value, even if it's imperfect. And then, of course, in future, you want to get more and better data.
Typically, because if you're going to wait until you have perfect data, you're never going to get there. It's a never-ending story. I don't think anyone here is going to raise their hand and say, I have perfect data.
Right.
Yeah.
Now,
And if I can add
please.
on, other than data, I think the biggest challenge is the customer's mindset in adopting AI. People expect that you're buying, people need to understand the difference between buying a mature tech versus any new tech, and AI is a new tech, right? So the expectations of the customer, what to expect out of the solution, the needing to understand that you're going to need to learn together with the tech is a journey that the customer needs to go through.
a customer's freaked out about the idea of facial recognition giving them, a credit score, being, their face becomes a passport to whether or not they get a loan or an insurance product. I think most of the world is not ready for that level of technology, right? Are you facing that pushback from customers? Are you facing pushback and concerns from customers that all that AI deployment, such as facial recognition, is too powerful? You know too much about them. Is that an issue for you?
I think the expectations is that the desire to know more, so the desire to do a POC, a sandbox, a pilot is always there, but the Six Sigma concept is still there, that it needs to be perfect before I can deploy it at scale. But AI learns when you deploy it at scale. It does not when you keep it in a pilot. So the immediate wanting at the POC to see super accurate results, I think, is the expectations that needs to be managed. Yeah.
So that's the human level. Tonio, actually, you don't really deal with humans, do you?
Well,
Sorry, we got feedback.
Sorry, no
Tell us
problem.
about some of the work you're doing on using AI to develop materials. That seems like a very unusual approach. We're all thinking about AI for better ads and showing you better cat videos, but you're actually doing something that is perhaps more practical.
Well, testing. Materials innovations transform your life, right? So everybody has one of these in their pockets, and there's about half of the periodic table in here, as well as many polymers, thanks to the hard work of material scientists for many years. So materials research is a bit slow. It typically takes 20 years to bring a new material from bench to business, right? And our job is to speed it up. It's a very different form of data. We're dealing with fewer number, but very rich data, a lot of descriptors per datum. And what we have to do, our biggest challenge is bringing the physics-based domain knowledge, meaning the textbooks, the brains of intelligent people, into the AI algorithms so they can be more clever in dealing with small data sets. So it's that combination of the human and the machine bringing those different expertise together that enables that factor of 10 or 100 or even 1,000 acceleration.
Give us an example of the process by which you might discover or develop a new material basically using computers.
Sure. So this is one of 20 materials we made last year. It was not planted. It just happened to have it in my pocket from a technical talk. It's a polymer, and it has it's a polymer with a very specific set of properties. So those of you who have picked up, for example, plastics at the Hawker Center would like those plastics to have certain properties that would make them more sustainable, right? So we're inching our way in that direction right now in collaborations across Singapore. So what we do is we take the available data and knowledge of how polymers behave, how they degrade, under what conditions they degrade, and start embedding these within AI algorithms. And then to make them more robust to real-world conditions in the laboratory, because those are messy places, we purposefully mess up the data. We purposely make it a little messy and copy and paste it a few times with different types of messiness. So the AI algorithms become more used to seeing messy data. This is a process known as data augmentation. but physics informed. And so it's through that process that we're able to train AI algorithms to be very robust. The predictive accuracy goes up from around 20% to above 90% once we train algorithms in this messy way. So I think the real trick is combining the human expertise with the AI. And you'll see this process replicated across many, many different fields, not only material science.
So what's in that little vial you've got there? Does it even have a name?
It has a name. It's a particular material called a polyoxazolene, for short. It's a polymer, a block copolymer that's comprised of many Lego blocks. And we've changed around the Lego blocks and the length of the polymer. Those are the so-called input variables into the AI. The output is something very simple. It's just the temperature at which this goes from being clear to cloudy. If we go outside afterward and get some hot coffee, I can show you it become cloudy. So that's one feature. Cloud point transition temperature. One feature that we're trying to engineer using 5 input variables, right? So those are the little levers. Those are the different ways you can cook the egg. And the property that we're targeting at the end is the color change. So this is a very simple example. It's targeting one feature. In the future, we'll be able to do 3, 4, 5 features, right? And that's a lot harder to do 3, 4, 5 things at the same time.
So does that mean could basically develop custom spec materials? Someone can come to you and say, I need a liquid that's going to change at 27 degrees Celsius with this level of transparency, and you can basically get a computer to put out the recipe for that.
Yes.
Wow, that's fascinating stuff. Element AI is back dealing with humans. You have to deploy in commercial spaces, right? You don't get the privilege of toddling around in a laboratory like he does.
Actually, we do.
Tell us about how you deploy.
We have 140 PhDs, so
wow.
We have a very strong fundamental
How many
lab.
engineers do you have in the whole company?
Well, that's very hard to say because there's software engineers and there's AI engineers. I don't know. The overall number would probably be over 50, 60. It's hard to know because we have multidisciplinary. How we set it up is fundamental research needs to influence the way that you build things.
Right.
I'll give you a concrete example. When you talked about the ability to, let's say, approve a claim for someone and the explainability of what the model did to approve or deny the claim, that means that you actually need to design the solutions to connect with humans so that they can eventually come up with the right learnings for the model. So that means that you are actually providing an explainability of the parameters that you use to approve or disapprove the model. Some of them will be valid, statistically valid, or the model is coming up with a trait that the human couldn't and say that's why we don't approve it. But there'll be things that the humans say, look, I know that you found that important, but in real life, that trait that you found, it's not relevant. So that the responsible way to deploy AI is to do it with humans in the center of things.
Human supervised.
Yeah, yes. Yeah, and not only supervised. You create a virtuous cycle of intelligence where humans become smarter because they get reflections of the kinds of inferences the model's coming up with that humans before were done unconsciously. Right. They say, I don't know why, but my gut tells me that this is wrong. Now the deep learning model is telling you it's not a gut feeling, it's an inference that is subconscious to you that can be exposed to you. So humans become smarter by using AI, and AI becomes smarter by dealing with humans.
So AI
and
becomes that sixth sense,
fundamental research.
Right, and so that brings me back to my next point. When you're talking about AI and humans are doing the research, what is it that AI is absolutely best suited for versus stuff that only a human can do? Because that's what we're at now, where there's a big concern that AI will take jobs, right? Well, we're all humans deploying it, going to steal our jobs.
Let's start with that. Human taking jobs is a fundamental design failure of humans building AI. Because what AI should do is augment capability of humans. We should be doing cognitive augmentations. We should let humans become smarter, more powerful by the use of AI. So when you say, I'm going to go full automation to just replace humans, you're taking a cheap, quick productivity approach that is actually not a sustainable design for long-term use of AI. And that's called being responsible in the ethics of how you deploy AI.
So what are the key mistakes that people make?
Key mistakes that people make is trying to substitute the ability of humans to run a process with accountability by automating. Making a decision on pitch a flight, for example, without having the pilot in the loop.
Right, so you still need that human to provide an input or a feedback.
Yeah, and you want the human to be exposed to advanced mathematical inferences. Say, look, based on this 100,000 data points, these are the top 3 things that could happen. What do you think we should do? And then the human basically is looking at those 3, and from experience, from tacit knowledge, from previous trainings, can come up and say, look, you know what, this first one, even though it's the one you recommend, this is the better one because it has other implications that you, as a model, were not built to consider.
So then, 10 years from now, which jobs do you think will be most AI-proof? The ones that will always need a human to do?
This is an interesting thing because every time I read something, I come up with 5 more options as to what else we can do with AI. What I think we can tell you is that cognitive augmentation would allow humans to become smarter. And I'll give you a concrete example. When you look at that AlphaGo movie, Lee Sedong, the world champion of Go, in the game number 4, did a move that it took 1 in 40,000 probability to ever do. And he admitted that he's never had to do that move before with any human. It wasn't until he faced the computer that he came up with that move. That move eventually created the 11th dan of Go, which did not exist before humans played machines. So in that moment, Lee Sedong became a better player by working with the machine. We believe that artificial intelligence will make us smarter if it's applied properly, which means any job, really, has the ability to become more productive, smarter. We move from being operators to become optimizers of our function.
But also, there's the issue there of, I guess, using the data, using the probability, and basically going counter. Like, if the probability is, 1 in 4 million, when you're against a machine, maybe that's exactly the option you should take, because the machine algorithm would not be optimized for that. I know you've got something to say.
Yeah, if I could just distinguish between general AI, which is what sometimes we see in the movies, it's a robot that's more intelligent than a human,
The Terminator movie.
and specialized AI, which is what we have today. Specialized AI is a cognitive assistant to help you perform your job better. It's designed by a human, generally, and it's designed for a human, the user. So in science, for example, we're designing specialized AIs to speed things up, right? For example, to speed up the structural characterization of a material, to know what we just made through our furnace. That has decreased the amount of time from around 4 hours to 5.5 minutes, thanks to a machine learning algorithm. So I would say there's cases of specialized AI, and exactly, you design it for a specific purpose. It's the embedded ethics in the designer that needs to be looked at.
Charles, I want to ask you, from your position at Appier, a similar question. What are the jobs that only a human can do that optimized for a human versus a machine? And 10 years, 5-10 years from now, what will those jobs be?
So if we look at what AI is good at this particular point of time, it's good at dealing with a lot of data. Okay, it's good at objectives that are very well defined. They're measured, right? So anything that can be put into this slot, I would say, is something like AI is good at. And like Tonio was saying, these would be very specialized, very specialized tasks, and a lot of AI development is doing that, right? So in terms of jobs or things that an AI cannot do, I would say that anything that's sort of open-ended, anything that's sort of creative, will still belong to a human, because at this point it's very hard to see AI getting at that sort of thing.
I know that I think we've all seen before deployments of AI or machine learning where they've taken a whole body of work and then tried to recreate, like, a Shakespeare poem. I guess the bots didn't like what I was talking about there. We've seen deployments of AI that have come up with attempts to replicate creativity in, say, literature, and have not always done that well. So I guess creative pursuits are the one area where humans will always be needed. One thing I want to ask Binro is, one of the concerns that I have, and I believe a lot of people have, is the deployment of AI and use of data to replace humans in the financial world, to the point where the fate of your loan application or your insurance will be based purely on a whole lot of data. There was a time back in the day where you'd go into a physical branch, you'd sit down with a branch manager, you'd have a conversation with them, they'd know who you are because you banked with them for many years, and you'd get a loan to buy a house. There's a lot of concern, for example, in China about social credit scores and you know, a little bit of bad data or some bad incident, and you're going to be locked out. How can you kind of confront that concern and be assuring everybody that they're going to get an equal shot, and one, you know, set of poor data is not going to have them isolated, and we're not going to have some kind of digital divide between people in society? That's a big concern that I have.
Well, I think it's the contrary. The people who walks into a bank and the loan manager knows you and you sure get your bank loan only applies to a small fraction of people. Most people, high chance, won't get a loan, even if they are entitled to or they really need to. So I would think instead of being exclusive, it will really be super inclusive with the tech. The exact scenario that you mentioned on the credit score, we have a technology called Microexpression analysis that we do a video call with a potential borrower. And it analyzes your emotion baseline first by asking you a lot of questions, typical questions that we know. So it analyzes the emotion baseline, and then it starts to ask you difficult questions based on our anti-fraud rules. So like if we know that someone who is a fraudster cheating a loan, high chance will not, or most of the time, almost all the time, will not tell you their real home address. So they will give you a fake home address. So we will still ask the home address and then allow Google Maps in the back end to dig out questions to ask, like where is the nearest train station, where's the nearest hospital, what color is the building, whatever, you know. So if you things that obviously you would know, so as to expose anxiety, anxious, uncomfortableness in the interview, that draws some statistics on red flags in the interview. This thing does better than a human because it's hard to hire people who are experienced enough.
That sounds like taking a polygraph test to get a loan.
A little bit, but the machine it's legal. It's not a legal document to say that you are lying or you're not being honest. It gives red flags so that the loan manager, the assessor, experienced or not experienced, have some data points. And this is especially useful if it's a customer without previous credit score, without an income statement, without something to mortgage, right? People who never had access to the loan could now have some level of statistics.
But don't you see the risk in that using things like, you know, virtual polygraphs? I can't imagine that there's going to be any bank manager who's going to want to like override the decision of a machine, because their manager is going to say, well, hang on, the data said this, and you took the risk and you overrode that data and made your own personal decision. I think in this day and age, we are so accustomed to believing computers and believing what data is told that it's actually a very big professional risk for anyone in a company to ignore the data they've been given and say, I know better than a machine, even though they may actually do that. But let's think about the bureaucracy of a company. That's very unlikely. So I'm curious to know how you can build those safeguards in to make sure that at the end of the day, a human is really making the decision.
Yes. You know, so it's important that you're not relying on one source of data. So and there are typical sources of data that the bank uses, and they still continue to use. Alternative data points are alternative data points. They're not meant to become the primary and only data point. So you cannot make a decision based on one video call and whatever statistics that whatever they give you, right? So the scorecard needs to be a balanced scorecard so that it's more information to a human being to make the decision instead of swaying the decision from one way to the other. And different countries, actually, the weightage of this alternative data differs. Yeah, and you have to learn along the way the culture differences, the human behavior differences. Yeah, as the volume grows, and then you tweak the algorithm to optimize it. So like you said, I mean, AI, instead of operators, people will become optimizers. But one thing I would add is that not everybody can become an optimizer. People have to be reskilled to become an optimizer. So that's a journey everyone needs to go through. Yeah.
Right. So I've got a last question for each of you. And since you've got the mic, Binra, I'll start with you. I want you to all look into your crystal ball and think, what is going to be a novel or unexpected or unusual deployment or usage of AI 5 or 10 years from now? Something that maybe we haven't seen yet, but you can see it on the horizon in your realm that'll be used 10 years from now. Do you have any examples of something that might be unusual or unexpected?
Well, personally, I think in 5 years or 5-10 years time, we should see AI cross-border benefit not just individual organization or individual nation, but allows or facilitates cross-border transactions better. Yeah, like today there's a lot of discussions about blockchain, and we feel that AI and blockchain are very together. That's the reason why OneConnect solution is all blockchain and AI. And when the two starts, if you see the trend of things, AI move a little faster than blockchain because AI is heavily dependent on computing power and data. It's more dependent on data than computing power, and blockchain is more dependent on probably computing power.
So you see blockchain and AI being deployed across borders
I
in 5
think
years,
10 years
right?
from now, the two will find a synergy whereby you will find solutions leveraging blockchain and AI together that facilitates cross-border better.
Right. Charles, gaze into your crystal ball for us.
I think one thing to really look out for is using AI for generation. If you look at the past few years, a lot of what AI has been used for really has been prediction, predicting something, yes or true. But you're starting to see cases where you can actually use AI to generate something relatively new. For example, last year, I think NVIDIA published a paper where it was, they were able to use AI to generate photorealistic pictures of fake celebrities, right? I took those pictures, I showed it on one of the conferences that I was talking at, and I asked people to guess which of these are fake, and nobody pointed to any one of them, even though all of them were fake. So this is actually something that I think will be relatively...
That's also very scary. Yeah, I think we might have all seen that website, this person is not real.com, I think it's called. And yeah, it creates very realistic looking photos of people that don't exist. Tonio.
Thank you. I think what you'll see is you're going to see people creating customized materials for customized solutions. Go out into your day and take note of every time you wish you had something better, something that lasted longer, something that performed better, that didn't crash. Take note of that. And now imagine a time in 10, 15 years when a scientist is able to work at the speed of imagination as opposed to the speed of the laboratory equipment today to design those materials. It might be a rural village in Thailand trying to adapt a new roofing technology to solve a local problem. It might be a company here in Singapore trying to develop a better encapsulation in a solar cell to make it last longer in a hot, humid environment, even though the solar cell was designed in a temperate climate. So you'll see the advent of mass customized manufacturing, the ability of manufacturing plants to retool on a very granular level to satisfy individual customer needs. The closest we have today right now is the automobile industry, where the paint job, the internal styling, all of that is customized for the end user in a just-in-time manufacturing process. You're going to see that more and more for materials and things that you use on a daily basis. Hopefully,
that's exciting stuff.
Sustainable. That's the big
Hopefully.
thing. Sustainable. 99% of people, I believe, are good, and that will carry the preponderance.
But a lot of us are
innovations.
lazy too, let's be honest. So
That's a good
an
thing
issue
for
with
innovation,
sustainability.
I think, yeah.
So Lewis, you've got the last minute. Tell us what you think is going to be happening 5 to 10 years from now.
Okay, I think that what's going to happen is you'll see the personalization of society and hopefully the democratization of that same capability. So what I mean by personalization of society is this. You will have a learning capability that is tailored to your own learning preferences and capabilities, your cognitive capabilities. So we no longer have to go through this ability to go through first grade, second grade, third grade, all standard and be treated as equal learning individuals, right? Instead, you want to be able to enhance your own cognitive capabilities based on your own parameters of learning. That personalization will extend to things like retail, where I'm going to pay the price that is made for me based on my ability to help or hinder the supply chain. Because today's supply chain is hugely inefficient, guys. There's a lot of trucks coming in with no load, and a lot of trucks going back with no load for no reason, which affects the price of everyone.
So we've got personalization at the material science level,
Yeah.
and then personalization for humans
Actually,
themselves.
this follows this.
Right.
Because these
They work
millennials that want their shoe the way they like it for the price that the other one goes and don't care that it's Nike or not,
Nice.
are going to drive things that they only will wear, and manufacturers are going to have to figure out a way to give them that, which means that personalization will be really powerful, because if you think about it from a dynamic pricing perspective, if you're willing to work and plan for what you want to buy, let's say you're broccoli, you may pay half the price for broccoli than someone that wants the broccoli right away at their door, because you're helping the supply chain.
Right.
So
That's
that's
a good
very
point.
exciting for me.
It's a good point to end, personalization for AI. So maybe it's going to be good for us humans after all. That's the end of our time. Please thank our panelists.